Hello.
Yes.
Loud and clear?
Yes. Can you see us by chance on the camera?
I should be, but
Okay.
I can't seem to find one.
Excellent. All the way from Atlanta, thank you for joining us. Go ahead.
Okay. So, a little bit about me. I'm Vishruta Rudresh, an IoT cybersecurity researcher at Kudelski Security. And my expertise ranges from developing proactive solutions for ICS security to developing new techniques using machine learning to contain IoT-related threats to enterprises. I'm also one of the leaders for the OWASP IoT project and a graduate of the Carnegie Mellon University. I'm a major anime buff and an enthusiastic hiker, and I recently scaled the Everest Base Camp for New Year's. So what is this IoT Top 10 project all about? So as it turns out, people tend to like the top 10 lists. And the 2014 list did not quite reflect the current threat landscape of the IoT ecosystem. Hence, a bunch of us IoT security experts decided to update this particular list. The list as such was created as a recommendation or an awareness chart on the current IoT vulnerabilities, say for manufacturers, retailers, enterprises, and consumers alike. The top 10 was also collated based on, say, some real-world vulnerabilities. The sources for this was mainly obtained from the National Vulnerability Database, the VRT, and other internally sanitized vulnerability lists. And the project also found its muse from other IoT-related projects from, say, the CSA, INSA, from Stanford University, and NIST. And currently, this is what the IoT OWASP Top 10 looks like. The heat map supposedly reflects how easily the vulnerability or the risk can be compromised remotely. So that was our ethos as well. The first one on the list is the weak or the guessable or the hard-coded passwords. So what this means is that IoT consumers tend to use weak or easily brute forceable passwords, or they sometimes tend to reuse these passwords. So if a consumer's password is compromised elsewhere, the consumer's IoT device also stands at the risk of being compromised. And on the flip side, we have the manufacturers who also tend to use hard-coded credentials, and they use these credentials across all their product lines. And sometimes they use the same password across all their product lines. Apart from that, they also included these particular credentials in, say, public forums, their manuals, their support environments. So, and apart from that, they also included, say, the backdoors in their firmwares or client software for port maintenance. And what this meant is that sometimes they forgot to close these ports once the maintenance was done. And this was a major issue, and one such issue popped up in Singapore, where a telecom support personnel forgot to close the backdoor post the maintenance of one of the routers on the telecom network, and the whole telecom network stood compromised. So next we have is like the insecure network services. So this includes mostly the unneeded or insecure network services running on the device itself, especially those that are exposed to the internet. These can include your telnet services or your UPnP services that are not guarded or closed when not required. So a classic example of the insecure network services being compromised was by the Mirai botnet. The Mirai compromised these IoT devices via the telnet ports that had weak credentials on them and used these compromised devices to create a massive DDoS attack. Then we have the insecure ecosystem interfaces. One has to recall that the IoT ecosystem is an amalgam of several technologies, such as the mobile, cloud, the device itself, and so forth. So what this particular point is trying to say is that The IoT ecosystem as such can contain insecure web interfaces or APIs, backend APIs may be insecure, and similarly with the cloud and mobile interfaces. So some of the common issues that you find in these are like lack of authentication or authorization mechanisms, or lack of weak encryption, and this can also include lack of input and output filtering. And this particular point is a little broad, and what the OWASP is trying to do right now is try and integrate this with the existing projects out there, especially when it comes to the mobile, cloud, and the web aspect of it. So probably in the future you'll see more. So then we have the lack of secure update mechanisms. What this implies is that devices tend to have the inability to update them, or there's a lack of, there's a secure mechanism in way you should be able to update these mechanisms. So this also includes legacy devices that are decommissioned and are no longer supported by the manufacturer but are still being used by the consumers. It also includes that the manufacturer does not provide the firmware validation mechanisms of the device, or the inability to deliver the updates to these devices in a secure manner. It also includes a lack of anti-rollback mechanisms in case the received update is known to be vulnerable and the consumer so would like to roll back to a secure version of the update. It also includes the lack of ability to notify security changes made to the device itself. So one such instance would be where a device resets the settings to the default setting post an update and the user is completely unaware of it. Yeah. Any questions? Could you repeat that, please?
Sorry, I'm asking chat questions. If anyone has messages on chat, give it a second. First question is, when did this project start?
Could you repeat that again?
First question coming in is, when did this project first start?
This project started sometime in the spring of 20.
The spring of what?
The spring of 2018.
Great, thank you. Another question is, how can people get involved to give data to this project?
We do have a Slack group. This is where I'm open this up. The details to accessing this is available on the OWASP IoT project page. And it's called the IoT Security Group.
Any local questions before we move on? Okay, we're good. Go ahead.
So next we have like a series of insecure or outdated components. What manufacturers usually tend to use deprecated software components or libraries to build their products. They reuse hardware components that are potentially vulnerable, insecurely customize their operating system platforms, or use third-party software or hardware components from a compromised supply chain. And I think all of you can agree with the last point, considering how hackers obtain their images. So that is something similar and similar to how devices are built as well. They don't use insecure components in the supply chain itself. Next we have is insufficient privacy protection. Manufacturers tend to develop devices that store users' personal information or some related sensitive information on the device or in the ecosystem itself. And moreover, they do not store them in a secure manner, or have well-established access controls or permissions, or use any anonymization techniques to obscure these sensitive information. Next we have is like the insecure data transfer and storage. What this implies is manufacturers tend to develop products that do not use encryption mechanisms to secure data while it is in transit or when it is being stored. So this includes, say, sending data in plain text or having no integrity checks and so on. Manufacturers also tend to provide inefficient access controls across the IoT ecosystems. This pretty much allowing any process to access any data at will. So in other words, they lack TPMs or TEs for some of the critical devices that we found out there. So then we have is the lack of device management. So what this implies is that manufacturers inefficient security support to deploy products. What they do is they fail to provide these security updates in a timely manner or not provide them at all. Sometimes manufacturers fail to provide secure decommission procedures to their consumers or their customers, leaving them at risk of being compromised. And consumers also, on the other hand, have inefficient asset and update management systems. They aren't aware of what devices are running on the network or how many devices are running on the network, what devices need to be updated, or do they even need to be updated. So they also lack these monitoring and response capabilities in the event of an attack. Consumers usually tend to be not prepared in the event of a decommissioning as well. What they do is they tend to use these products well beyond their lifespan, and that leaves them vulnerable to attacks. So next we have the insecure default settings. What this means is that manufacturers tend to deploy the devices with insecure default settings, such as being unable to change the passwords or have weak password policies to begin with, or that they have insufficient security configurations itself. Say they just have two access control accounts, one with the admin access and one with the user access, or sometimes they don't have a mechanism that allows the user to use the type of encryption. Say, do I want to use 2048 or the length of the keys that I want to use for encryption, so like 128 or 256 or something like that. So the last one is the lack of physical hardening. Here, manufacturers and consumers tend to not provide physical security measures to their products in general. Manufacturers do not provide, say, tamper-resistant mechanisms such as locks that usually are provided on electric meters, or provide tamper detection mechanisms such as an alert mechanism that could be sent to the consumer or a manufacturer in case the device is tampered with physically. So consumers too do not tend to protect their devices from physical harm or monitor the device's ecosystem, say, from plausible insertion of rogue devices. They fail to provide physical protection mechanisms like barbed wires or secure entry to the device premises, or maybe just have a secure camera. So, any questions out there on the OWASP top 10? IoT top 10.
Another meeting on project. Oh, it was Steve Templer. Yep, your mic was open on your laptop. Okay, go ahead. Sorry.
Yeah, you asked for questions, I got one.
Can you hear Bill?
Yes, I can hear you loud and clear.
Hi, with all the issues that you see in IoT that you've laid out for us, has anyone considered a reference model? In other words, developing a good example and sort of presenting it?
So that's part of our next steps at developing an IoT architecture.
I hear you. That might be a next step. Okay, I was just offering it for consideration because it's really quite primitive, as you've clearly laid out. So maybe you need a positive reference model and say, well, here's an example that met this, or even identifying an example already that would meet it.
So, the question for
We did not have enough time to include to add use cases in each of the mentioned points or the category of vulnerability that's been listed. But then this is an ongoing project and everyone is welcome to contribute. And we need as much help as we need. We can get sorted.
So this is Tom. I have a question. Actually, my question's for Bill. So Bill, as a senior security architect for a large financial, what examples could we use or reference for this project that they should look at and say, here's an example of a reference architecture that's useful in the real world? Would you maybe have a one or two?
Not for IoT, but well, no, I think someone should have somewhere a positive reference for IoT that, who knows, NIST came up with, the government came up with, and we can say, we just point to it. No need to build it, just point to it.
Is anyone aware of anything that falls into that category? This is where we collaborate.
Because this sounds like 1980 PCs, you know, so in order to move forward, a good example would probably be a good idea.
Any other questions, or we continue on? All right. Go ahead. Go. I don't see any questions in the chat either, so go right ahead.
Some of the challenges that we identified was the one makes it hard for manufacturers and consumers to secure these IoT devices, right? One of the primary reasons is that the IoT ecosystem is very complex. It's an amalgam of diverse, independent legacy devices that intertwine so communication protocols, interfaces, and people.
Oh, you just lost her.
Thank you. So basically, this complexity of the IoT ecosystem hampers the ability of the security professionals to exercise those basic cyber hygiene techniques, such as keeping an inventory of the hardware and the software components on the company network, or identifying and disabling those vulnerable applications, and consistently backing up data or patching those applications immediately, and so on. The second one was identified as IoT systems can be inherently insecure. So there are multiple factors that attribute to this. One is the lack of security by design expertise from the manufacturers, and they have the paucity of incentive to develop security controls in these devices, or maybe it's just a pure implementation problem that makes these devices so vulnerable. And finally, there's the IoT standards and regulations, which tend to be very obscure and underdeveloped. There is a lack of a mature security framework to develop and deploy secure IoT products. There is no approach, nor there is a common multi-stakeholder model for cybersecurity. So companies and manufacturers rely just solely on their understanding of security to develop these products. And since there's no regulation that exists to force these manufacturers to develop secure products, it just goes back to the second point where IoT ecosystems can be inherently insecure. So, but we did think of certain recommendations along the way. But these are recommendations that we'd like to recommend to enterprises at some point. And this includes deploying the security configuration and operation management systems. Most of them already have them, but then tweak them a little to include the IoT devices as well. These systems will ensure they'll ensure the integrity and confidentiality of configurations made to operational elements of the system, including endpoints, communications, monitoring, and management systems. The second one is have something to do with data protection and compliance. Include systems that involve, say, scanning your data repositories and resources to identify existing sensitive data, classifying it appropriately in order to identify compliance issues, applying the right security controls, and making decisions about the storage optimization, deletion, archiving, and legal rules. They must also try and find a way to provide visibility into what sensitive data exists and where, as well as monitor and log data across permissions and activities. This is something similar to what already exists, but what makes it difficult with IoT devices is the logging itself. You cannot, currently none of the devices have logs on, neither do they log on the cloud mobile systems. Then we have some sort of identity and access management because they enable a secure management for your IoT devices. Then we have some security monitoring system, say security monitoring gathers security-related event data, aggregates, correlates, and analyzes it. So continuous monitoring verifies device behavior and assists in detecting these malware, security policies, failed authentication, so on. So, but personally, what I think what works best is network segmentation. So it is recommended that networks be split into segments, with each segment containing assets with similar security policies and communication requirements. And each segment then be assigned a trust level, and all communications into and out of the segment can then be monitored and assessed. And just have network filters. Use network filtering techniques like air gaps, firewalls, message rewriting, proxies. You need these to prevent unauthorized connections to your networks and so on. So we have load balancing as well. It is recommended to enterprises to use DDoS resistance and load balancing infrastructure that inherently does not trust data received and always verifies any interconnections. So having robust policies and procedures for, say, risk identification and management, incident response management, and training your employees on basic cyber hygiene techniques can reduce risk of compromise as well. Lastly, we have the physical security, such as lock up your server rooms, authorize only internet users with least privilege access, log and monitor the access via video service, and prevent portables from connecting to your devices, use key logs, fire extinguishers, and things like that. Yeah. So lastly, no matter what, some of these devices is going to be vulnerable, and the employed security controls may not just suffice yet. So what we would recommend is use compensatory controls. For instance, if a certain port needs to be kept open at all times in the device, and the device is connected to the internet, the port as such should be monitored, and the applications connected to this port must be whitelisted as well. So any questions?
Are there any easy cost approaches? I'm just thinking of the consumerism. I'm thinking the consumerization of this, of the ability to make a device cheap enough for our buy it.
She can't hear you. Sorry, guys, that's what we can do.
Are there any lowest cost, easiest approaches to attack some of these items? And I think about it from a consumerization point of view and making these devices cheap enough for homeowners to buy them. You know, where would we look first? from just trying to do some of this very cheaply?
Did you hear that question?
Are you asking huge institutions?
In the consumer space, are there any easier items to attack first? There's out of these 10 top problems, are there some that are easier to solve than others without driving a high degree of cost?
Are you showing us the answer?
Maybe you're on mute.
Yeah. The easiest way to attack any devices is obviously via the guessable password, right? So in educating users to use strong passwords would be the first step and the easiest and the cheapest. And I know it could be the hardest as well.
So a question coming in on the chat from Emilio is he thinks cameras are a prime target. Do you have any comments around cameras being a prime target?
For one, they're always connected to the network and they're always online. Some devices tend to go offline security required to be online at all times. So it makes it easier for the hackers to be present in the network at all times, so they don't get out of the
Okay. Another question from Michael Waters is, first and best step is to segregate OT from IT. Do you have any comments about that, being a professional in this space?
Well, that's changing, right? People tend to, or people want to connect both IT and the OT together. So, but I do agree they need to be segregated.
Any other questions from this side? Okay. That looks like all the questions. Do you have any other final comments or suggestions based on what you do every day in the space, pen testing these devices?
What I think is most of these issues can be solved in the design process itself. People need to pay attention to the kind of features that they put on these devices, or just developing those applications for these devices for that matter. Just doing the basics can go a long way. And I'm sure all of you are experts out there, and I would like people to come and join our IoT group and contribute as much as they can.
I have one more question has popped up. Question around being able to hash firmware updates on embedded devices. Do you have any suggestions in context of hashing firmware updates on embedded devices?
Hashing. Oh, what do you mean by hashing?
That's the question, unfortunately. So hashing the firmware updates might be tied to making sure the executable that's going to be flashing the device has a unique signature.
It is a recommendation that most of these updates do have with signatures, and devices need to have a mechanism to verify that. And if hashing also implies obfuscation of these updates, I would agree too.
Okay, thank you.
Was that the question?
Here's a statement from Emilio. Maybe this question answers Bill's point before, that he's used in this cybersecurity for IoT program guide for guidance and best practice.
Cool.
So they may have something available.
Okay.
Has OWASP used it?
No, one of the members of the one of the remote attendees suggested looking at the NIST standard best practices.
That is one of our muses for generating the list and the recommendation.
Could you maybe bring up the OWASP project page to show people around on how that looks and navigate for them so they can see it?
Yeah.
You still only see your OWASP top 10?
Yes,
Okay, thank you.
and this is what the page currently looks like. We have the IoT top 10. Updated. We have the IoT attack surfaces area. This is where we are going to include some of the use cases and examples that is addressed. This is where we tend to include the latest vulnerabilities that we find in each of the categories listed. This also requires to be updated. And as for joining, you should join here. So we have other related projects currently that we're working on. It's called the IoT Code. The purpose of this project, I don't think the project is to say one and users how to. So most of the top 10 vulnerabilities will be included in this particular framework.
Anything else to add?
The testing guide also needs to be updated. It's not for link. And we're trying to link this to the other OWASP projects and should be updated by the end of the year or hopefully before autumn. That's it from my end.
Okay, great. So we close. Any last questions, and then we'll let her go.
Yeah, just one last potentially dumb question. So, for those devices which are associated with a consumer, as you pointed out, in the financial industry, of course, the price of identity management when you're talking about the public is pretty high. And for years, they would simply rely on some kind of initial identity proofing, like you opened an account with us, and we know this information. In the IoT space, where they are associated to a person, has there been any usage of things like a consumer database that might be used today for fraud prevention, or you say your bill, you say you're at this address, we have an associated phone number, can we send you an OTP, and you'll enter it. In other words, the device is just the pass-through for an out-of-band authentication. Has that been considered with some devices? Does that sound as if it would in any way help? Because that was sort of the crawl step that we ran into over time.
Let me summarize our question. Are you asking me that are there any devices out there that could be used to authenticate users and eventually prevent fraud?
What I'm saying is that, like consumer devices trying to do banking, you don't have a lot of horsepower, you don't have a lot of security strength. So we simply used it as a pass-through to do some kind of out-of-band authentication. And the one that seems to be working for low assurance is an SMS OTP to a registered phone number, simply allowing someone to say, yes, I've installed my thermostat. Okay, great, let's make sure it's you. Is that use case of, do you see that kind of use case in the IoT devices you're attempting to secure? Does that have any value?
It does for information content. If you're using it at your home and you're installing, say, maybe 10 or 15 devices, but then if you expand this to include it in enterprises, then it's going to be really difficult. To get an OTP for each of the devices is going to be difficult. But if this process is automated and the devices are going to do it themselves, that would be nice.
It's quite limited, but it's a start. So thank you. Okay.
Yes, what I'm trying to say is if the devices do that themselves, a rogue device would be able to do the same thing. And it would be hard to differentiate between a legit device from a rogue device.
Excellent. Well, thank you for your time and joining us from Atlanta to talk about the OWASP IoT project. If people want to get in touch with you, do you have any contact information or a final slide?
Yeah, let's see.
Excellent. Thank you. So for the people that are on the, thank you for joining us. So for the people that are on the webinar, our next session is going to start at 7:30. So we're going to take a little bit of a break for networking, get some food, maybe have some discussions here, and then we'll reconvene at 7:30. That's what the schedule says, so we'll try to stick to the schedule. So thank you for that, and we will keep the bridge open. Thank you.
Thank you. Thank you.